Okay, AP Calculus, video 6, I guess, video part 6 for AP Calculus and chapter 2 continuity. We ended up with this function in the last video, and we said this function will not be continuous, which is secant x on minus pi by 2, because secant x is equal to 1 over cosine x, and cosine x is not defined. Cosine x is equal to 0 at minus pi by 2 and pi by 2, and this interval included these two values. Number 6 is the interval do not include these two values. That makes the derivative equal 0. So it is continuous. Yes, it is continuous at this interval. Number 7. Number 7, for what values of k is the function given here, f of x, continuous at a point x equal 4? Let's start with the conditions we know in continuity. First, we have f of 4, right? F of 4 equals what? F of 4 equals, we substitute 4 instead of x in the in here, right? Because x less than or equal 4. X equal 4 is here also. So we substitute instead of x 4. 4 square minus 11 times 4 minus 4. 4 square is 16 times 3. It's minus. It's 4 square is 16 times 3. It's 48. Minus 11 times 4 is 44 minus 4. So the answer is 0. F of 4 is equal. F of 4 is equal to 0, right? What else? This is condition 1. Condition 2. Condition 1 exists, right? All of the conditions exists because it's giving continuous. He's not asking me to prove it continuous. He's telling me it is continuous, and he's asking me to find the value of constant number k, right? Let's continue. The second condition, we have to find the limit for limit of f of x as x approaches 4 minus, right, is equal limit of which part of f of x? X approaches 4 minus means where x less than 4, so it's also in the first one. Limit of 3x squared minus 11x minus 4 as x approaches 4 minus, it's equal also to 0. And what is the limit of f of x where x approaches 4 plus? It's equal to the limit of f of x. What is f of x? It's kx squared minus 2x minus 1, because where x greater than 4, this is 4 plus here, right? So as x approaches 4 plus, the answer will be 16k minus 8 minus 1, which is 16k minus 9. 16k minus 9. Okay, the two limits should be the same. Why? Because this is condition 2, and condition 2 should be applied because it is already given as continuous. Since f is continuous at x equal 4, this means the limit of f of x as x approaches 4 plus is equal to the limit of f of x where x approaches 4 minus. X approaches 4 plus, we just found it, 16k minus 9, and we found where x approaches 0 minus, where x approaches 4 minus, sorry, so 16k equal 9, we divide by 16 both sides to get that k equal 9 over 16. So we found k. We should see if this k is correct. It should, this is the second condition, and it should also satisfies the third condition, right? Where k equal 9 over 16 now. We have it equal 9 over 16. We found it. The limit of f of x as x approaches 4, which is equal to 0, right? As x approaches 4, which is equal to 0, because if we substitute instead of k16 over here, it will give me 0. And f of as x approaches 4 minus also equal to 0, and that equal to f of 4. Therefore, the solution is true for k equal 9 over 16. We still have 3 numbers in this set. Number 8, we should find also the values of k in this function. Also, it's given as continuous function at x equal -3. Okay, Let me also just erase some, to have some more space. Let's erase what we did in this one. Uh, we have to solve number 8 as exactly we did in number 7. It's the same, right? But let's see what we will have. First condition, right? First condition, which is f of minus 3. First condition is f of minus 3. What is f of minus 3? Where x is minus 3. So we substitute minus 3 here. K squared minus 5k, right? K squared minus 5k. This is f of minus 3. Now, second condition, limit of f of x where x approaches negative 3 minus. What is negative 3 minus? It's here. What is that equals to? It's the limit, right, of f of x, which is negative 6x minus 12, as x approaches negative 3 minus. We substitute negative 3 instead of the value of x. Is the answer will be negative 18, negative 12. So the answer we have it is 30, and oh sorry, this is plus 18, right? Minus times minus is plus, so the answer is 6. All right, this is as x approaches negative 3 minus. Now what is the limit of f of x as x approaches negative 3 plus? We take it where x is greater than negative 3. So its limit of 6 where x approaches negative 3. 6 is a constant number. There's no place for x to substitute. So the answer is 6, not negative 3. So we have both sides equal, and this is condition, and this is condition 3 applied, where the limit of f of x at x approaches negative 3 is equal to what? Is equal to 6, right? What else? Condition 3. What is the condition 3? Condition 3, the limit of f of x where x approaches negative 3, which is equal to 6, it should be equal also f of 3. And we find f of 3. It should be equal because it is given continuous, right? Again, it's k squared minus 5k. So it's k squared minus 5k. By other words, k squared minus 5k minus 6 minus 5k minus 6 is equal to 0. So we have a quadratic equation now. We solve this quadratic equation by delta or by guess and check. We factorize it. This is simple quadratic equation. K negative 6 times positive 1 is negative 6. If we multiply the means, will give me negative 6x, and the extremes will give me positive negative 6k, sorry, positive k here. Negative 6k, positive 1k, it gives me the middle one, which is negative 5k, so we are correct. What are the values of k here? K minus 6 equal 0. We find that k equals 6, and or k plus 1 equals 0, it gives me k equal minus 1. And remember, here we have two values, and remember the question was, what are, for what value or values of k is the function f of x continuous? For these two values, we found, k equals 6 or k equal minus 1, the function f of x is continuous. We still have two numbers, 9 and 10. We solve them in the next video.